Hello. Hi everyone. Good evening. Am I audible? Hello. Am I audible? Let's wait till 6:10, 6:10. After that we'll start. Okay. Anand, am I audible? Hello Anand. Yeah, good evening. Thank you. Just a second. So yeah, till now we have completed week 10. Okay. Now right now we are recording week 11. And currently the attendance is 3 plus me 12. So that is 3. We'll keep on increasing it. Swaroop. Swaroop. Uh, let's wait till 6:10. Okay. By that time, some more people will join and then we can start. Uh, that I cannot tell. Like, even I don't know. Is there a question paper, previous year questions? Actually, the questions which you guys get in exam are only visible in exam only. Like, I don't know the questions which you get because those questions are prepared by professors only and they are directly sent to NPTEL team, so I don't even get to see them. So those questions are only visible to the people who have given exam. Assuming that the questions are changed every time. Otherwise, I don't know. Like assignments are changed, so I also expect the exam questions are also changed. See, if it's an MCQ or say if it's a fill in the blank, then also you will get MCQ type of thing. Okay, so you will get multiple options. You will get multiple options to basically fill the then you have to fill the MCQ from that it will, you will have multiple choice questions only. You will have to click, you don't have to type anything. That makes checking easier, obviously. So yeah, let's wait for 2 more minutes, or 1 2 minutes. Sometimes people join by 6:20 or something, so I don't rush things. I just take time to start, because like I don't think so you guys have any other doubts. By the way, let me share one thing. So in April, today is 4th. Then the next session will be on 11th of April, and one extra session will be on 12th of April. That is Saturday. Okay, 6:30, 6 to 8. So the attendance 1, 2, 3, 4, 5, 6. Until now, 6 people have joined. 1 more minute. Let's wait for some common faces. They join usually at that time. Okay, 6:10 it is. We are so tight on clock. So last final audio check. Am I audible? Okay, thanks. I need to put my face here and share my screen. So the screen should be visible. Is it visible? Okay. Let's discuss this week's week 10. Next week's week 11 deadline has passed, day before yesterday. Okay. So any doubts in week 10? If you have any doubts, then let me know. Otherwise, I will explain all the questions one by one. I don't think so there are any doubts. Okay. So When estimating the parameter for a Bernoulli distribution using maximum likelihood estimation, what is the formula? Okay, so formula is this thing, this small m by capital N, and this was also in last year's week 10 assignment, so I've explained it. You can watch the video and you will be able to find. If you have any doubts, then just let me know. I have to keep on increasing the counter here, sorry about that. Okay, Prabhu is also here. Hi Prabhu. Good evening. So I think you were there in last week, right? We explained this thing m by n. Yeah, there was some example. Okay, so anyways, central limit theorem. It says that when you have like I'm just telling the basic definition. It says that if you have any huge amount of some data and you take out some samples from that data and you take the mean of those samples, then the mean follows Gaussian distribution. So that's what happens here also. What happens to the distribution of sum of n? Okay, so sum is basically mean into that number, so it becomes Gaussian. Okay, so that is the answer, Gaussian. When covariance matrix is proportional to identity matrix, covariance matrix is proportional to what shape of contours? So I think we solved it. We didn't solve it, but anyways, let me just, I have to write, otherwise I will just ask ChatGPT to prove it and then I will show you. In that way, so I will paste the answer in docs and then we can see. It's a beautiful explanation. Okay, so it's not giving equations. Anyways, let me switch screen to ChatGPT. And do this one. Is this thing visible, GPT? So, okay, thanks. Some new people joined? No, okay. So, multivariate Gaussian PDF is this thing. If you search Google, it's a very basic formula. When this is equal to this thing, okay, so you get this expression, okay. So as you can see, it's symmetric in all directions, and this is a equation. This is the equation of circle. This is the equation of circle, something minus something whole square. So in 2D it's circle, 3D sphere, and D is hypersphere. So it's just this equation of some body, some point whose locus is same in all directions, something like that. So the answer is circle. When using naive-Bayes classifier for prediction, what rule is used to assign a class to distribution? That is maximum appropriate posteriori rule, but not distance, not this. It's this one. Any doubts till now? Guys, any doubts? Okay. Yeah, so given data set with features X and classes C, naive Bayes is you have to find class given a feature is directly proportional to you have to find class multiplied by you have to find feature given classes. Features given a class is derived applying which of the following. So it's Bayes theorem. Naive Bayes already tells the Bayes theorem. And when the answer is Bayes theorem is solved, obviously conditional independence assumption. So we have to assume this conditional independence, otherwise we won't be able to multiply this thing. Okay. So this is this thing you have to remember. Why do we assume this conditional independence? What is the probabilistic interpretation of least square cost function? It maximizes posterior probability. No. It minimizes Bayesian error. It maximizes likelihood of observing data given the parameters. Yeah, this is the correct answer. It maximizes the likelihood of observing the data given the parameters. So why? So once you say create a pen type of thing here. Okay, so follow my mouse tip. Okay, follow the tip of the mouse. Now this cursor. So assume you have this curve, and data is here. So if I don't minimize this, so the probability of finding data on this curve is very bad because the data is very far. Good evening, Praveen. Praveen, please, like since now we have, this is the third last session, try to join on time. Like you missed a lot of interesting stuff going on earlier. Okay, so by the way, I told in the announcement that we have an extra session on April 12th. That is, April 11th is the last session, 12th session, and April 13th will be an extra session where I will be asking, like I will be revising all the assignments from start to end and like all the stuff which you have been taught. So that way you can make bullet points what things you have been taught, and that will help you ultimately. Okay. So yeah, that I was telling. See, assume this data is near this PCA word and your line is near this prediction word. So the, what do you say? Likelihood of finding the data on this line, like this line is a parameter, is very poor because the data is here. So if you apply this least square function, this line will come closer to data. Now it will maximize the probability or likelihood of observing data given this line. Okay. So that is why it is the correct answer. My iPad is actually down, otherwise I would have connected it. But it takes a lot of hassle to connect iPad and wastes a lot of time. So okay, so PCA has generally SVD. These LU decomposition, QR decomposition are different. They are not exactly PCA. They are sort of similar to SVD, but they are not exactly PCA. Okay. So which decision boundary supports SVM? I already told in last class also. This is the answer. I will solve it again. I will solve. Let me check my iPad if it's charged or not. It's a lot of hassle to. Actually, my openness. I don't use iPad a lot. I open this for your sessions only on weekends. Okay, it's charged. Let me connect it. So, what screens are visible to you right now? one should be iPad and one should be this main screen. Okay, it's showing, right? Okay, so let me start. Because some of the questions require some things, I don't think so. Like, you have been taught the way I learned it. I'm just telling my perspective to solve those questions. Okay, so that's why I need something to write in. Okay, so this one I discussed. This was an interesting question. The solution I showed on ChatGPT. Once I upload the video, you can also see it, and you can also copy it and write it down. I won't write it again. This one I told. So yeah, this one, question number 6. So assume I have these two axes, and this is some data here, and this is your parameter line. So there's a gap here. So what is the probability given this parameter line the data is here? It's quite low. So I apply here some mean absolute error or mean square error, and this line comes here. And now the probability of finding data near this line is high. And if I come very close, now this thing becomes very high. So this is what mean square error or any error does. Least square cost function or anything like that does. Got it? Any doubts here? Praveen, Prabhu, rest of the people. Okay. This one basic. This one was an interesting question. I tried to explain it in some higher dimension last week. That wasn't visible to you. It was only visible to me, but let me tell you. So assume this is a plane. Let's not draw it like this. Let's draw it like some parallelogram. Assume this is a plane. So what is the equation of a plane? No, but that is the equation of some line. So what is the equation of plane? Any 2D plane, just assume 2D plane. What is the equation? That equation should be constant, right? Correct? Let me explain you by giving an example. Okay? This is x-axis, this is y-axis, this is z-axis. What is the equation of x-axis? Any point. Am I audible, Prabhu? Praveen, Prabhu, what is the equation of x-axis? Rest of the people, can you write it down? In a yes, if it's 3D space, then it's either y equal to 0, z equal to 0, but I will combine together. If it's 2D space, it's y equals to 0. Okay? Now what is the equation of xy plane? Any point that lies on xy plane will have z coordinate equal to 0, right? Just all the things will change, but this thing will not change. So yeah, so plane for plane, z equals to 0 will be the equation. Okay? So you can see, right, for any plane the equation is the line orthogonal to it. Correct? Prabhu? For any plane, the equation of that plane is the equation of line orthogonal to it. Right? So assume I have the line here, or assume I have line here. These two are parallel lines. So these lines are multiples of each other. Right? The equation will be, simplified equation will be same for these two lines. So if says this is 3x plus 2y equal to 0, then it will be 6x plus 4y equals to 0, something like that. These lines are same lines, just they are parallel. Okay? So this is what happens. So for any plane, the equation is the equation of a line perpendicular to that plane. So assume this line has some equation x plus y equal to 0. Assume it. Okay. Any point that lies on this side of the line and any point that lies on this side of the line. Okay. So what is the distance of this point from this plane? And what is the distance of this point from this plane? So that distance you compute is by using this line. Okay. Got it? So basically you compute what is the distance of this line from this point. So that is basically, so this point you assume x1 comma y1. So this distance becomes x1 plus y1. Okay. And this distance becomes, say this is x2 comma y2. So this distance becomes x2 plus y2, right? Correct? Answer me, guys. Answer the question. Till now it is correct. Prabhu, Praveen. Praveen, you're not. Yeah. Can you hold on a second? Hi, sorry about that. My internet actually is kind of wonky. Hi, sorry about that. My internet has some issues. It happens quite a lot in IIT here. Let me just start. Uh, I'm just assume it. Just just assume it for now. Just assume it. Okay. I'm telling you that just assume that this is the equation. But for a plane you don't have to square it. Okay. When you find the distance from one point to another point, then you have to subtract the difference and square it. For plane you don't have to. So I think my iPad isn't visible. Yeah, start sharing it. It should be visible now. Not visible. It is visible. See? It is visible. Yeah. Okay. So see, when you find distance of a point from a line, the equation is like this. You put this thing here, and the value which you get. Let me show you. Let me show you. Let me show you by an example. So assume this line is 2x plus 3y equals to 0. Okay. So assume, I mean, this point does not have any y-intercept. So does point 0 comma 0 lie on it? So if I put 0 comma 0, you get 2 dot 0 plus 3 dot 0 equals to 0. So this means this point lies on it because the distance is equal to 0, right? Okay. So take another point, say minus 3 comma minus 2. So 2 dot minus 3, minus 3 comma plus 2, plus 3 dot 2, this equals to 0. So this means this point also lies on the line. So you don't have to square it. If you square it, it will never be 0. Okay. So this is how you find the distance of a point from a line or from a plane. Okay, so this is a perpendicular plane, line to the plane. So what happens is this line is in this direction. Okay, the line. So assume you have a plane, you do this this Fleming's right hand rule, and the direction which point upwards is the equation of the line. So you swap the plane. If it's an xy plane, you do like this. If it's a yx plane, you do like this. So right now the equation is pointing upwards. Okay. So see, this point lies on this side of the plane where the equation lies. So this thing will obviously be greater than equal to 0. Greater than 0. If this point comes here, then it will be equal to 0. And for this point, since it lies on the opposite side of the plane, this value is less than equal to 0. Less than 0. And if this point goes here, then it becomes equal to 0. Right? Okay. So now you know that x1 plus y1 equals to 0 is the plane. And if a point is, yeah, so if the point is greater than 0, it is on that side of the plane, and if it's less than 0, it is on this side of the plane. So for all points of two classes, so class 1 should be here, assume capital Y equals to 1, and class 2 should be here, capital Y equals to 0 or equals to minus 1. Okay, so whenever it's 0, you assume minus 1. Why? I will show you. So what is the equation? How is the decision boundary is represented? Decision boundary is represented like this. Like this. If it's greater than 0, it is on that side of the decision boundary. If it's less than 0, it is on this side of the decision boundary. Correct? Okay. So now what you have to do is, how do you learn this thing? So what I do is, so since x1 plus y1 is greater than 0 for positive data, for say class 1, and x1 plus y1 is less than 0 for negative data, that is class 0. We also assume it minus 1. I will tell you why. Okay, so what you do is you basically multiply this class y into this is x2 comma y2, x1 plus y1. So this is plus 1, right? So positive into positive is equal to greater than 0. Correct? So this means that if I multiply correct data point with its class, the answer is greater than 0. If I multiply correct data point with its class again, this y is now 0. Assume this is minus 1. So this is minus 1, this is negative, it will again be equal to 0, greater than 0, right? Okay. So that way you can tell, if you multiply the distance of a point from a plane in times the class of that data point, it should always be greater than 0, or it should always be less than 0 if you switch this thing. If you put my negative class this side and positive class this side, but it cannot be different. It should always follow the same sign. It should always be greater than 0, less than 0. So that is how you determine if a point lies on this side of the plane or that side of the plane. Correct? Prabhu, Praveen, correct? Okay. The problem is, this is the whole setup for logistic regression. Like in this line, this equation, everything is correct, but this greater than 0 and less than 0 and whatever it is the setup for logistic regression. What is SVM doing here? SVM is saying, let's push data points as far as possible. The plane should be in perfectly between. So the distance should be at least something. It should not be greater than 0. It should not be 0.00001. Okay, it should be at least 1.00001. So what they do is, instead of greater than 0 and less than 0, they ask the model to do this, or some constant k. Less than 1, greater than 1, greater than 2, like that. So in that way, the plane becomes more stable. So assume I have this set of data points here, positive, and this set of points negative. This is positive, this is negative. The plane here, it is perfect for logistic regression. But SVM says this plane should be perfectly in between. It should be a, so if you draw a convex hull around it, it should be a perpendicular bisector. The plane should be perfectly between. So this distance should be sufficiently high, and this distance should be sufficiently high. So what should be this distance? They assume it, they put it. So this distance should be at least 2, this distance should be at least 2. As far as possible. Okay? Or at least 5, or at least 20, or at least whatever it is. Okay? So this is why if you see, mm-hmm. Mm-hmm. Correct, correct. Hmm. So why we are doing, I've already told, to basically make these signs same. Okay, if these signs are different, it becomes very difficult to be manage, like determine which class of the data is going where. Why isn't it erasing? Okay, so if I switch the y's as well, if I switch the data, if I say assume this equation is in this side, this line is in this side and not this side, so this thing will just be opposite. This whole thing. How? Now this will be less than for both of them. So that's not an issue. The signs will be same. That is the whole point. Irrespective of equation of the line. Okay. So yeah, that is all. This is perfect logistic and this is perfect SVM. So as you can see, this is the decision boundary, but this should be the condition followed by an SVM model. 1 or anything or any k, it should not be greater than 0. So see, for positive class, no. For data points to be correctly classified, this should be the expression. That's what I have explained here. Got it? Okay. Last question. What would the how would the methodology change if maximum likelihood any question? Okay. Estimation assumes errors from follow distribution different than Gaussian. Maximum likelihood estimation assumes errors follow a different distribution than Gaussian. If a different distribution is different, the cost function will become different. A different cost function, yeah. Cost function will be different. Mathematical solution is possible every time. It's like a closed solution. If you even if you follow some different distribution, the solution will always be closed because you are assuming this thing, maximum likelihood estimation. This always assumes the closed solution form. So yeah, this is the correct answer. The different cost function would be derived. So week 10 clear? Week 10 of last week. I mean of this year, week 10. Week 11 deadline is still there. So we will discuss it next week and week 12 next to next week, or maybe on Saturday itself, okay, because I don't think so we will have another date to discuss. But I will discuss all the assignments and possible concepts at once on my iPad, and so just be present. Okay, so moving to my courses last year, moving to last year, and so last year's week 11, for your help I will solve. I mean, some questions are very basic, I don't need my iPad. Bayes theorem, this is prior, right? This yes, Praveen. What question was that? Conditional independence. Why conditional independence? That was the question, right? See, Bayes theorem, you already know, it follows Bayes theorem, it's visible here, it's Bayes theorem only. Conditional independence, if you don't assume, this is one condition, this is another condition. These two conditions are independent only if they are orthogonal, right? Okay? If you don't assume it, it's not a naive Bayes because you have to multiply every condition. If they are not independent, they are dependent. If they are dependent, so some part of that lies here, some part of that lies here. If you multiply them, yeah. Chain rule, it is chain rule, it is chain rule only. You're multiplying it, it's chain rule, but the assumption is conditional independence. Chain rule, I mean, no. Chain rule is different. Chain rule, in this context, this is not chain rule. Chain rule is when you multiply, when you take one condition and when you take previous condition on which this condition was dependent. So chain rule is applied in deep learning when you back propagate. Okay, I mean chain rule is very specific about that. If it's not some arbitrary term. Chain rule is only used in back propagation. And it's clear, like it's naive Bayes. So what theorem will it be? Bayes theorem, na? Obviously. Correct? Praveen? Okay? So it's not. Hello? No. In forward pass, we don't apply chain rule. It's only in backward pass. Otherwise, see, forward pass is very simple. Forward pass is some f of g of h of I of j. Correct? If you take derivative of this thing, it becomes very difficult. You have to compute derivative of everything, and ultimately you will have a very big memory. But what you do is when you backprop, you compute derivative of this thing, then you derivative of g of something, then h of something, then I j of something, then I of something. So why can't we use the derivative directly from here? So that is why I apply chain rule. So we basically, so what you do in this case, what is the derivative? Derivative is dou f into dou g into dou h into dou I dou j into dou I by dou x, something like that. Okay, by something. So dou f by dou g by dou h by dou j by dou I. Okay, this is chain rule. So you already compute this thing. Once you compute this thing, you can compute this thing as well. Then you can compute this thing. So you already know these values. So that is how you chain rule efficiently manages the memory. Otherwise, it becomes very difficult to manage memory for every computation again and again if we have to store it. If we don't store it. Okay. So coming to, let me upload this just in case I forget. Going to drive. Sorry, not here. Okay, so let's start. This is likelihood, this is prior. We already know like basic terms. Given this prior, what is the probability of this thing happening? So this is what we do in Bayes theorem. and Bayes rule. Recall that maximum and likelihood, we try to estimate parameters in which we maximize. However, in maximum posteriori estimation, we assume our parameters are a random variable. We have two distributions prior of this thing theta and this thing. We have this thing, obviously we are multiplying this thing. Assume that we have set of diagnostic experiments for which identically independent distributed, and for the Bernoulli principle, assuming that we have theta greater than 0 and less than 1, we have the data set this, given that Bernoulli trial likelihood function is defined as success should be 2 by 5. I mean, it's clearly visible, 2 by 5, m by n. We have already told na this rule, m by n. So given that, so if you see this formula, taking derivative of, so this is what this ML equation is. If you take derivative of our expression, equate it to 0, we find roots at theta equals to 0, 1, 2 by 5, and it can be also seen from here, like its 5 values are there, 2 are positive, and just 0. So since we want to case the number of success is 2, so that answer is 2 by 5. That was the formula, right? M by n. P to the power m dot q to the power n, where n is equals to n minus m. This is what Bernoulli principle, Bernoulli theorem is all about. Correct? Guys, it's clear? As I already told in last week 10, right? Week 10 I already told this formula, m by n, right? First question itself. Okay? So it's either that way, and that formula is derived from this thing. So if you take derivative of this thing, okay? If you take derivative of this thing, okay, so you get these three roots, and you will find maxima at 2 by 5. That's given here. Okay, let me solve the question from here only. Generative models are a class of algorithms used in machine learning to make model distribution of data. These models are capable of generating new data instances that resemble the original data. Within the scope of machine learning paradigm, which category of generative models do they fall? So do we have labeled data? No. We have unlabeled data, and we don't train a model on unlabeled data, then it becomes unsupervised learning. So what we do is we take some sentence and we try to predict the probability of next token. So that comes under unsupervised learning. Even though generative models can also be used in semi-supervised setting, when you have to label the data using some next word prediction and next token prediction, but it mostly falls under unsupervised learning. For more to learn more about this, you can just go through this course, NPTEL large language models. Okay, you can go through this course. I will share the link here. NOC 45, CS45. This one is CS49, I guess. Just go through this. If you find it interesting, you can enroll, or you can just watch the videos. Okay? Any doubts till now? In the context of machine learning models, a fundamental distinction exists between how models approach learning from data. Based on this distinction, which of the following statement accurately differentiates generative model from discriminative model? So discriminative model try to learn conditional probability. What is the probability of next token given this sentence? While generative model try to learn joint probability. What is the probability that these two tokens exist together? Okay, so I'm not reading this thing. I know I'm working in NLP, so I know the answer. I'm just telling you the answer itself. So generative models usually model joint probability, while discriminative models learn conditional probability. If you are able to see my iPad screen, I will write it down. So discriminative models ultimately mean some BERT type of model. So what is the probability that the class of y is 1 given that sentence is something. Okay, while GPT model, they try to do is, what is the probability of these two words existing together? Boy comma good, its probability is low, but good comma boy, the probability is high. Okay, so this is joint probability distribution and this is conditional probability distribution. Correct? Any doubts? Praveen? Okay. Nice question. For a particular training iteration of GAN, suppose generator G has improved, leading the discriminator D assigning the following probabilities to generated images. Based on these outputs, calculate the generator's loss, which aims at maximizing the error of discriminator. Hint, the generator's loss is given below. Given discriminator's output for these images, calculate the generator's loss. Generator's loss is log of D of G of Z. So you take the output of generator, you apply output of discriminator over that, you get this thing. This is the probability, right? You apply log, that will be basically summing this whole thing. So log of 4,5 is this, log of 5,5 is this, log of 3,5 is this. This becomes this. Okay, so there are three values, so you average it. So you remove the negative sign, so loss becomes this thing. Okay. So, yeah, it is given, right? Yeah. Okay. Do you know what a GAN is? Do you know what a GAN is? That is the full form. Okay. So take an example. I have right now, you can see me on bottom left of my screen if it, I don't know. So there I have an image. Okay. I will ask GAN to produce a similar image. Okay. The problem is, if a GAN gives me exactly same image, it's also an output, right? So that's why we apply discriminator. So this is generator, this is discriminator, this is Sahil, okay, and this is Sahil again. The problem is, if this is Sahil and this Sahil is equal, so the image is same, there is no generation happening here. It is like just copying the same image from here to here. I don't want that. So what I do is, I pass this Sahil to discriminator. So this was some joint probability distribution. What is the probability of this Sahil and this Sahil existing together? Two Sahils are as it is. The probability is like this distribution and this distribution are same. So probability is very high. Okay. But discriminator says what is the probability. So discriminator, basically we have to maximize the loss. Okay. In most of the models we have seen previously, we try to minimize the loss. For discriminator we try to maximize the loss. So what we do is, instead of doing W is equals to W minus some alpha times dou L by dou W, we add this thing. Okay. Why are we trying to maximize this loss? We are trying to create a completely different image. So what I do is, I pass this Sahil and this Sahil here, and I ask, given this Sahil, what is the probability of this Sahil happening? So correct. If it's trained best, if it's trained very good, it will give me like this is very high thing happening. But what I do is, I maximize this loss. Okay. So now it will give me a when these two images are same, it will give me very poor value. But if these two images are different, it will give me very good value. Good value means high value of loss. And I want that only. Like if two images are same, the loss will be very high. If images are different, because the task becomes different, the loss will become low. Okay. So that is what we want. So what you do is, you take, so assume this Sahil is Z. You apply generator over here, you get Z1. Now you apply discriminator over this one. So you apply discriminator over this one, you get 0.45, 0.55, 0.35. Generator's loss is given below. Calculate generator's loss. Generator's loss is obviously. So how do you guys calculate the loss? of three images. So this is lost, this is lost, this is lost. You can multiply it, or you multiplying it will become very small. So what you do is you take log over it. So you take log, log basically adds them. So you get log of loss is 0.8154. Okay, easy question. Is my screen visible? Laptop screen, not iPad. I'm closing the iPad for now. I will show you iPad later on. Okay. So if you're able to see the Sura website, right? It's visible, right? Let me show you this. So these are basically diffusion models. Okay, these are basically diffusion models. They are sort of similar to what GAN used to do, but they right now the GANs are not being used anywhere. Like in very, I would say, very high performing models. So I will show you here only. I'm not able to do picture in picture. I don't know. Anyways, so assume a cat catching fishes with fishing rod, or an orange cat. You might have come across these types of videos on, what should I say, on Instagram. You might have come across these types of videos where some cat is catching something. So billions of AI research and people are generating this type of thing. So I usually come up. So this is what diffusion models or GANs used to do. So it will give me 3-4 images. So how it is differentiating that these 3-4 images are completely different? It is applying a discriminator over backend just to check these images are different. Otherwise it will give me same images. The variety will be very poor. Just wait us for a second. It's taking some time. It generally takes some time. Not visible. Still running. Mm-hmm. Yes, please go ahead. Yes, yes. Mm-hmm. Okay. I will explain. I will explain. So, what is latent? Latent is something. Let me tell you the exact meaning of latent. Existing, but not very noticeable. What happened to my? Let me just stop sharing one. Let me share again, or let me join again. I don't know why I'm not able to click anything on screen. Yeah, now it's something. Something happened. Am I audible? I'm not able to click. Like, see, I can. I'm not able to even end the call. Let me. Am I audible? Am I audible? Okay, so as you can see, latent is something that is existing but not noticeable. Okay, not obvious, not noticeable. See, nice cat. Let me create video. It creates very nice videos. I do like. I'll show you. I'll show you. I'll let it create some videos here. Actually, it's a paid thing, so it sometimes like for free. I don't think so. It works or not. So if you go to my media, I'll show you like what I tried creating and relaxing cat fishing. Okay, this is the image. This was some monkey making moon. So I asked to create a monkey making moon. This was an actor dancing on a train. So I tried to create Chal Chaiya Chaiya, but it created something else. See, poor, like it's very poor, but yet it's a researcher killing his supervisor. Let's yeah, toy train. This one was a researcher killing his supervisor. Let's not go there. Yeah. This is Sora. This is Sora of OpenAI. Okay. I tried to create Obama and Osama playing chess. It did not create. Content might violate our policies. A lion with the head of Obama killing a gazelle with the head of Osama didn't create. Black Barack Obama killing Osama didn't create. Girl playing table tennis hitting smash against Serena Williams. So, like, see, if you see each frame by frame, girl can get 2 hands, 3 hands, how it's going from here and there. And AI is very poor. Like, it's generally giving an abstract idea, but it does not focus on details. Details are nice, like you can see some text written there, some advertisements, but see what's happening. Where the racket is going, where the girl is going, anything is happening here. See, this girl got 2 rackets here. Generate a video of rabbit chasing down a lion and killing it. See. So this rabbit becomes lion, that lion becomes rabbit, and I don't know what's happening. Okay. So anything is happening here. So let's go to what cat is doing. Yeah, so very basic. Relaxing cat catching fishes. So this is what this AI does. It creates pixel by pixel, dot by dot, but those dots are connected. Okay. So someone was asking something. Week 10, week 11, I don't know. You guys has had some doubt. Yeah, latent space. So you know the concept of vocabulary, right? So assume no, not per se. Like if I ask you to tell me ABCD and you tell me from Z to A, you're not missing out on an alphabet. So see, and you can jumble them. You can ask QRST, ABCD, yeah, any random order. So vocabulary is the thing is, yeah, they should not repeat, and it should be complete, exhaustive. Okay. So it should be independent. Every word should be independent. That's what I was saying. Orthogonal. Why orthogonal? If there are 2 A's in the vocabulary, now which if I write some sentence in that it has an A, I would not be able to point out to which A I am referring to. Correct? So that's what orthogonal means. They should be completely independent of each other. Okay. Next thing is, this should be exhaustive. Vocabulary should be exhaustive. There should not exist any letter outside in a sentence that is not present in vocabulary, or any word outside sentence that is not present in vocabulary. So given like in the context of letters, let me ask you water. I've been shouting. I had a class today, so I was shouting there as well. So this is letter based vocabulary. In word based vocabulary, if I tell you, like in dictionary there is almost every word present which is not which is present in this world. Okay, correct. So that dictionary is a vocabulary. I cannot say any word that is not present in any dictionary. So vocabulary is something that way. So if I ask you to represent, a sentence using vocabulary, if I give you some index, so this word is 11, this word is 12, this word is 13th, and vocabulary size is very big, so like it's in 3 million or 3 billion. So that sentence, for that sentence to be represented, I will say if word number 1 is present or not. If it's present, you will write 1, otherwise 0. If you do for million times. So that becomes the embedding of that sentence. Correct? So the problem is that embedding is very big. That embedding is not latent. It's there, it's visible, it exists. I will try to map it down to some smaller space, some smaller latent space, so that it is representative, but it's not an existing sort of setup. Okay, so I will represent from 1 million to some 800 words or 800 latent features or latent basis vectors. Those vectors are orthogonal to each other, like this, like this. Okay, so that is just a representation. So that does not mean an exactly same physical representation, but that is a latent representation in some reduced number of dimensions. Okay, what do you do in PCA? Yeah, sorry. A set of orthogonal concepts. That is the correct definition. That is learned by some distribution. So you have some data, you convert that data to some distribution. So model learns those latent spaces from that distribution only. Okay. Let me give you another example. What example I was about to tell? Okay. I was about to tell something. In GANs, in PCA. Assume you have 20 features, but your model can only handle 10 features. What you do, you perform PCA. From real features, you get some latent features. Yes. Yeah, I remove unwanted features, but the features which are remaining are not actual features. They are some latent features that represent those actual features. Correct? If I try to point out this data point belongs to this feature, what is the name of this feature? I cannot tell because that is a latent feature only. Okay. Yeah, so that is what GAN is about. That is what everything is about in NLP. Something is happening to me. I'm fine. So there's a segmentation task. Two algorithms. Algorithm A. Yeah, I am drinking. I have finished half a bottle. I will in 2 minutes. Otherwise, just let me read the question. Okay, so there's algorithm B. You have to use this algorithm to segment tumors. Okay. Performance is evaluated using dice score. So if you know, segmentation is evaluated using dice score. Intersection over union type of thing. Okay. So assume this green part is your actual tumor. This is the segmentation which you got. Okay. So if intersection is very poor, you will get 0. If intersection is complete, you will get 1. It's like that. Okay. Okay, common metric for assessing similarity between algorithm predictive segmentation. In particular, image ground truth has 1000 pixels. Algorithm A identifies 900 pixels as tumor, of which 800 are correct. This means the intersection is 800 divided by 1900. Correct? And yeah, 1000 plus 900. Okay, so 800 divided by 1900. Algorithm B identifies 1100 pixels as tumor, of which 850 are correct. 850 divided by 2100. So see, 2 into 800, this is the algorithm. We multiplied by 2, right? We saw here. This 2. This 2 is here. So here's this. 2 into 800 by 1900 and 2 into 850 by 2100. So answer you get is somewhere around this thing. Okay? Got it? Praveen? Okay. Based on the calculated dice scores for algorithm A and B, which algorithm demonstrate better performance on segmentation task? Jagar coefficient type of thing. Yeah, so if I just give you the number of overlapping pixels, the problem is that you will not able to determine the size of the boxes. Okay, so that is why you divide by sum of that to get a relative score. Okay, algorithm A performs better because it has given more segmentation accuracy relative to ground truth. Algorithm A performs better, obviously. You are estimating probability of coin landing on heads using map. Your prior belief is that head is slightly more heavy. Your observation in 10 flips is that you get 10 heads, and map will be closer to 1 because since the prior favors heads, data is also supports as, and you get 50% of this, so it's already skewed towards head and times 50%, so you're getting values closer towards 1, not 0.5. Had it been an equally likely weight, this would have been towards say 0.5. Okay, but I think there's something wrong. Head, if the head is heavy, the head will come towards down, the tail will be on top, but the prior favors heads. This should be like it's some physics wise it's not correct. Getting my point? If you take badminton shuttlecock, that head is heavy, tail is light, it always lands on head. Okay, so if head is heavy, the tail should be more probable. Getting my point? I mean, it's pretty obvious. If you want tail to come, you make the head heavy. You want head to come, you make the tail heavy. Okay, so second last question. In GAN, what type are of generate two neural networks against each other? What is the distinguish real data? Obviously, in GAN, generator tries to create realistic data while discriminator acts as critic, trying to distinguish between real data. This competition helps generator to improve its ability to create realistic and convincing output and somewhat different output. That's what the question of Ganga was. I think you had the question, Ganga, right? So it basically, this competition of discriminator helps it create a realistic and convincing image that are not exactly the same as original image. Loss function of GAN, you can already see like this is 1 minus d of g, discriminator over. So it's either this or this. Okay. Then you take discriminator, this thing, so option p data d p z. Okay, so initially you take expectation from x, then you take expectation from z. Z is the output of discriminator. Okay, so this is wrong because initially you don't take expectation from z. The original distribution is from x and then you take from z. for discriminated part. Okay. So yeah, that is the correct answer. This is how we end week 11 of this week. Last week will be week 12, where we'll discuss the remaining, and then on extra day we will revise everything. Extra session. Okay. April 12th, I think. I emailed them April 12th. But anyways, they will let you know, and if I will see, I will inform you. I filled Google form, but I don't have responses of that form, so I don't remember exactly. MCQ, everything is MCQ. Yeah, I mean, that is a possibility. If it's a multiple select question, you will be able to see. The check boxes from radio will be in form of square. Okay. So O means it's single correct, while this thing square means multiple correct. Okay. Any other question? I don't know. I mean, exams are easier. NPTEL exams are comparatively easier. You just have to revise everything, revise all these questions in assignments. 30-40% weightages from these assignments only. 30-40-50%, around half of the paper is around from these assignments only. I mean, the answers will not be exactly the same. The questions might not be exactly the same, but the format will be same. Yeah, I mean, if it's you are asked to find in a class of 20 students, 5 are boy and 15 are girl, what is the probability of picking up a boy? Answer is 5 by 20. The values will change. The question will be same. Or boys and girls can switch. So don't mug up the solution. Just go through the concepts of solution. Try to revise. Start revising from today itself. And if you have any doubts in weekly session, we will discuss the previous assignments as well. Okay. 1, 2. Yeah, 1, 2. Week 11. Any doubts? We will discuss in next week and next to next week. Next and next to next week. Okay. Start solving. It generally takes 20 minutes of your day to solve the assignments, and 2 hours a day to study for the course, max. If you have already studied, I mean for revision task I'm saying. Okay, so for a week. So you have to spend like 4 to 5 hours a week to study for a week from start. So like 12 weeks are there. For 12 days, if you do like 3-4 hours a day, you can easily like score in 90% or something. Okay. Okay. Chalo then guys, let's meet next week same time, and then on the next day itself of that next week, consecutive sessions on 2 days, and then let's see how much can we finish. Sorry. Yeah, April 11th and 12th. We have sessions on these 2 days. Okay. Same timing, 6 to 8. You have which one? Anyways, I record this, so you can watch the recording. Okay. because I cannot change it now. I have already given it. Okay, so you can watch the recording on YouTube. The sheet has these links. The sheet is already sent to you in this thing in the announcement section. You will be able to find it. Okay. Okay then. Chalo. If any other doubts you have? Okay then. See you guys next week. Bye bye. Take care. Happy weekend.